Hi, I'm Dave Robinson, Chief Data Scientist at DataCamp, and welcome to another one of my screencasts where I analyze a dataset that I've never seen before. Each of these datasets comes from the Tidy Tuesday project put on by the R for Data Science online learning community. And so I'm excited to see what this week is going to bring for me and what we can learn together by analyzing this data in R. This week is going to be New York City restaurant inspections. That's exciting to me because I actually live in New York City. I wonder if I'm going to see any restaurants that I recognize here. And it's going to be data from the New York Open Data Portal. All right. That's exciting. All right, so let's read through this for 1 second. Okay, you can read in the original data set. Yeah, I think I'm going to read in the full large one probably. Download the data directly into R. So we shared a data selection. Okay, I'm going to keep the full version. All right, so what I'm going to do is open an R Markdown, right? Create a new chunk. I don't need the seed if I'm reading it in. And I'm going to call it restaurant. What is it? Restaurant inspections. Try running this. This might take a minute. All right. That's going to be exciting data. Oh, clean names. All right. I'm going to go ahead and call this restaurant inspections raw. I'm going to do the same kind of cleaning here that the original post, that the R for Data Science recommends. So I'm gonna, here we go. Oops. I actually don't have the janitor package installed right now. I'm gonna install it. That's for cleaning data. All right. And I'm gonna run clean names. And now if I look at restaurant inspections, aha. Okay, so here's the data, 380,000 rows, and let's find out what the columns are. Okay, so I wonder, does this come from an article? And I'm going to find that out quickly. So it's great, this is a 538 data set, so there's probably a cool article about this, but I usually don't read the article before I look at the data. All right. So we have an ID, a unique identifier, doing business as, a name, the borough. I'm going to view this so I can see a couple examples. So borough is like Bronx, Manhattan, Brooklyn, Queens, Staten Island. Zip code, a description, there's like a category, a date of inspection. This comes in month, day, year format. Action up. So I guess each of these, it looks like is the date of inspection, then what happened in that inspection. So it says like violation, or it says it was reopened, reclosed, violation cited. All right. This is going to be really fun. Critical flag. Is it a critical violation would be a question there. A score. All right, this looks like, what is that on a... maybe a 0 to 100 scale. It's not that easy to tell here. A grade, I recognize these. You can see these up posted on restaurants. And then the type of inspection. Inspection program, type of inspection performed. See data dictionary for full list. So I'm not going to look at the... It looks like we have some graphs here. I'm not going to take a look at those. This is a really cool data set. All right. How am I going to clean this data? Well, one thing I want to do is I see inspection date is, here we go. Inspection date right now is month, day, year. I really want that to be a date object. So I'm going to do MDY from the Lubridate package. MDY month, date, year of inspection date. Now it's been turned into a data object in R. That'll be easier to transform. All right. Violation code. I wonder, do those... So I think that's related to violation description. All right, one thing I wonder here is, does the ID... does the ID in this, like, Camus is that an inspection ID? or for the restaurant? Oh no, it's static per restaurant. All right, so I'm curious how common are particular inspections. By that I really mean how many inspections do we get per restaurant? So I'm gonna quickly add this to the cleaning step. Okay. And if I do count DBA, we have 384,000 inspections of 21,000 restaurants. Oh, but some of them, like Dunkin' Donuts or Subways, are chains. They happen to lots of people. I'm going to use CAMAS. I don't know. Again, it's like ID of their restaurant. So it looks like some restaurants had many. Yeah, some individual restaurants had many inspections. All right, that's super interesting. Okay, what period of time are we looking at is another question that I have. I usually start these data since I get a feel for each of the sections of data. Like if I want to look at change over time, I'm going to want to count year is the year of each inspection date. And I wonder, all right, looks like almost all of them are 2015 through 2018. I'm probably not going to look at this per year. The reason is like, I don't know that there's really meaningful change over time, and there may be a selection bias because you notice we have fewer in 2015 than you do in the following years. I don't think that's because like so many new restaurants have opened or the inspections became more common. I think it's just that I think it's just that we have a selection bias of more data from more recent time points. All right, that's cool. I wonder if I set month is month of inspection date, and I view that, I'd probably want to sort it first, sort it by year and then month. Okay. Yeah, it looks like we have more and more data from recent time points and then a lot more in 2017. Okay. I'm not necessarily going to want to look at things over time unless I'm looking within one restaurant. All right, that's worth noting. Okay. And I'm just going to leave the count by year here. I'm interested in what the grades were that resulted. So if I do count grade, sort equals true. Okay, A, B, C, Z, P, G. Wow, what a situation. I wonder, I'm wondering if there's anything in the grade associated with the inspection. Pending. So A, B, C, Z is grade pending, and P is grade pending for reopening. Okay. So you have some A, B, C. Okay. And what does it say about the score? It doesn't total for particular inspection. Okay. All right. I'm going to take a look I'm going to probably return to score, but I'm going to take a look at the violation description because that seems interesting. Count violation description. Are they really common? Okay. Oh, yeah, they really are. By common, I mean, do we see the same thing again and again? And we do. So this first sentence, I'm going to try something. I'm going to try head to grab the first few rows. I'm going to do pull violation description. I want to read the whole message. This looks like a long sentence. Non-food contact surface, improperly constructed, unacceptable material used. So-and-so not probably sealed, raised, spaced, removable to allow accessibility for cleaning on all sides. This looks like a description, and oh no, not vermin-proof, evidence of mice or live mice. Oh, this is gonna... how am I going to have lunch in New York again after going through this data set? It's going to be all right. But what I was saying was that we have these long messages, and they look like they might be unique. But in fact, we have 53,000 separate inspections that get this violation description. So these are boilerplate messages that sounds like maybe they're selected from a list. And I bet if I count the violation code alongside the description... Yeah, we have that's what 10F means. Okay, so this is really useful. This is saying that let me see, each row is a unique identifier for the restaurant. No, I'm wondering, is each row unique for a restaurant and an inspection? That is a question I should have asked. What I want to know is, let's say, can one inspection lead to multiple violations? It would make sense that it could. Let's find out. So what I would do is look for the ID, doesn't hurt to have doing business as, and also the inspection date. Yes, it looks like, for example, Brothers Fish Market on September 25th of this year, 2018, had 16 violations in that inspection. Let's take a quick look to confirm that that represents 16 separate violations. So I'd say inspection date is this date, 16. All right. Wow. Oh boy. Violation description 16. This is not a place I would want. Live roaches present. Flipping out here. So one thing we learned from this is that some violations are critical, some are not critical. And score looks like is associated with score is associated with one inspection. So this had a score of 80. This also gives me the sense that higher score is bad, because this definitely looks like a bad situation. And maybe you add for each additional violation. So this would be, I'm guessing, one of the highest scores we have of 80. All right. And some of them are critical, some of them are not critical. This is a cycle inspection or initial inspection. I don't know what a cycle inspection. Okay. Does that mean, I wonder, does that mean the restaurant is not open yet? It says see data dictionary for full list of expected values. I thought I was in the data dictionary. Okay. But yeah, so this is something we're learning. All right. We have violation codes and descriptions. We have score that sounds like it's given to an entire inspection. We have critical and not critical. Okay. And we have cuisine. Okay. All right. That's some good exploration. I'm going to keep exploring a little bit because I really like to get a feel for all these categories and what they mean before I start to answer questions about the data. What's our common types of cuisines? We have 85 types, mostly American, Chinese, formatting issue here, but there's a cafe, pizza, Latin, Italian, okay. And one thing that I'm thinking about is this is a seafood restaurant. Seafood, maybe there's more that can go wrong in a seafood place in terms of violations than in a cafe. So one thing I'm curious about is maybe if we compare those two those cuisines, we'll see some having more violations than others. Okay, so to do that, I'm just thinking about I'm concerned that some actions, I should really look at actions too. Some actions might not be associated with the same kinds of data. Mostly it's violations cited. Sometimes it's establishment closed and violations cited. Sometimes it's no violations. So if I filtered for action being no violations, what I understand is what's interesting to me is it says no violations, but some of these rows we actually do have a violation code. Maybe it means there's a not critical. So if I quickly counted the critical flag, count, Okay, so we have critical violations, not critical violations, and likely mostly in these actions where it says no violation needed, it'll say, it would say not applicable. All right, and if I take a quick look at this and I count critical flag, were there any, this sounds like a data entry error. There's a couple cases where it looks like it's critical, very few, and then it says no violations. So it sounds like maybe inspectors make mistakes, or maybe they allow one not critical and they don't even let it by. Okay, so I might be interested. All right. I'm going to be interested in everyone's most recent inspection. Let's say we started there. So let's say I wanted unique items, unique inspections. So these are all one row per violation per inspection. What if instead I wanted one row per inspection? What I would do is group by the ID, doing business as. Doesn't really hurt to group by the borough and zip code too, and the cuisine. These are all restaurant-specific things. And of course, very necessarily the inspection date and the action, which we believe are always the same across one inspection. And I'd summarize to say, how many violations are there? That would be the sum of all the cases where the violation code was not missing. So now this group by and summary is going to be one row per inspection. So here it's like, how many violations? This many. All right. And what I also might want is, that's number of violations, but I could have done it actually as critical violations. That'll be sum of, here it is, of, where is it? Critical flag is critical, so all the cases where it is critical, not including the missing values, and then we'll say non-critical violations. We're going to throw score in to the things we're grouping by, and grade. That's a good idea. I already said action? I think I already said action. Okay. Yeah, so this is going to be an aggregated version. So I'm just going to call this inspection. This original data frame, I'm going to save this. This original data frame had a misleading name of inspections. It really should have been inspection violations. After I do the summary, I'm probably going to want to ungroup. Okay. Okay. I feel good about this because now we have 146,000 separate inspections. So for example, here's a I'm not sure, a bakery in the Bronx. We see an inspection in February 2016 and then May 2017 and May 2018. Each time it gets a score of 5 or 7 or 10, it gets a grade of A. And in the end we have each time about one critical violation, one non-critical. This would be seems to me like a pretty good set of results. Okay. We also have ones, interesting, we have these are some that go with this Wendy's in Brooklyn, where it generally has low scores. Weirdly, it doesn't have a grade. I want to see somewhere there's inspection type. What was it called? Inspection type. This is slow because grouping by loads of columns is just kind of a slow operation. Not really a good way around that. Cycle inspection. All right, so now if I count, what are the types of inspection? Or at least the most common types. Most are either initial or a cycle inspection. Okay, and a cycle is going to be... Oh, no, I don't think this is either. I think this says most of the time it's initial inspection, sometimes it's a re-inspection. Some of them come pre-permit. Okay. We have a whole bunch of types of initial inspections. Okay. Yeah, so it sounds to me like cycle means like kind of routine. It can be initial reinspection or reopening. We really want to separate these. What are the two types? They are the program and inspection type. Okay, I'm going to add this as a cleaning step. What I'm going to say is separate inspection type into two columns. One is inspection program. The second I'm going to call inspection type. And I'm going to say sep is, this is a great tidy operation, separate. I'm going to separate it based on that slash. So I'm renaming, like I'm replacing that old, what used to be called inspection type. So now if I say count your inspection type, it's going to say mostly initial, some reinspection, some reopening. I could also count the program. I'm going to see it's mostly cycle, some pre-permit, and so on. Okay, let's say I wanted to just do cycle inspection. I don't know, I could do, okay, I'm going to say, let's just do cycle inspections. I don't know how it's going to differ between these programs, but I'm going to go with the most common one and say filter inspection program. Oh, I'm going to run this, and I'll need to include inspection program as one of our grouping variables. And I'm going to say inspection program equals, what is it, cycle inspection? Love it. Okay. And if I counted the grade that's given during a cycle inspection, I still don't know what to do with all this missing data. Okay. All right. I'm going to start here. And then I'm going to say most recent cycle inspection. I'm just going to go with that. I'm going to take this as a... and I'm going to do it on their initial inspection. Some of them maybe... It sounds to me like it goes initial inspection, then maybe a re-inspection. Like here, aha, look at that. There was an initial inspection and then a re-inspection a couple weeks later. I don't know why they did a re-inspection when it looks like they had no violations the first time. But let's say I want to say most recent initial cycle inspection. What I would do is say inspection program is cycle inspection. Inspection type is initial inspection. And how am I going to do most recent? I'm going to arrange by descending inspection date and distinct the restaurant ID with keep all equals true. Now there's only one for every restaurant. All right, so these are 22,000 restaurants that have at least once gotten an initial cycle inspection in this data set. And this, if I want to look at a restaurant level, this would be one good option for looking at that. I could have included the re-inspections. I could have included, I could try and turn into time series, say here the many times been inspected. But let's say I just want to look at like across restaurants. Okay. Then I can discover some things. I can say, one question I have is do some cuisines have different scores than others on average? So I can group by the cuisine description. This is kind of a category. And summarize the average score is mean of score. I bet we're going to have some missing data. Wow, I haven't seen any missing data here. Never. So disregard that. I also might want to say the median score. And I want to always include the number of restaurants. I'm going to arrange by descending restaurants because I want to say, so here we have mostly American, then Chinese, then cafes. And is there a difference in their scores? Not crazy, not huge that I can see. Italian, let me see, Latin tends to be a little higher. The lowest here is cafes. I did suspect earlier that cafes might be, might just have a fewer chance. They tend to have small kitchens, so they might have fewer chances for violations. Okay, but that's one way I can look at it. I could also say by borough. I could say group by borough, and say mostly we're in Manhattan. Very similar across all 5 boroughs. Tiny bit lower average in Queens, Bronx, Staten Island. All right, that's interesting. If I look at these inspections and I look just at the score, and remember, higher is worse. Higher means more violations. If I look across these and say, let's see, what's the distribution of scores? Yeah, I expect to see something a little like this. We have a peak that's low and then a high, like a long tail of higher and higher scores. Okay. Okay. And that's definitely interesting. So I would stick with this restaurants. I'm going to keep it going by cuisine description and say, let's see. I'm thinking about how best to represent this. Ideally, I'd want confidence intervals. Is a t-test really appropriate for this? Not hugely, but I'm going to do it anyway. Really, it might be more like a log t-test, but I'm going to start this with I want to get confidence intervals on each of these. I want to say, like, is it actually true that in general cafes have the fewest violations while Latin restaurants have the most? Let's find out. what I'm going to do is say by cuisine. Then I'm going to say, let's take the, nope, my bad. What I need to do is, okay, I'm going to change how I approach this just a little bit. Watch this. We're going to use the broom package. We're going to say, take our data set, nest it by everything besides the cuisine description. And now, if I took one of these data sets, how can I perform a t-test to find the confidence interval for the score? Well, what I would do is say, model is use pers map to data. Say on each value, we're going to do t.test of $$ score. So if I said like t.test of 1, 2, 2, 2.5, something like that, I get this one sample t-test that actually has a confidence interval for the mean in the middle of it. So if I run, I'll have to remove any cuisine that only has one restaurant here. I can do that with an add count cuisine description, filter n is greater than 1. Honestly, let's filter n is greater than 100. If you don't have 100 examples, I don't think it's that meaningful to examine. Okay, heck, I'll make it 200. Now we have 27 types. All right, I feel a little better about that. Now that I've created these hypothesis tests, what I can do is tidy them. I can actually say unnest map model tidy, and tidy comes from the broom package. Keeping our nested data over there, but tidying turns each of these into a data frame, in this case a one-row data frame. We have a confidence interval with a low and a high. So this is kind of notable that based on the assumptions of the t-test, we can see a confidence interval for delicatessens that is, for delis, that is higher than for American restaurants, so American food. So we actually can see some differences here. What I would do with this plot, this I'd call cuisine confidence intervals. And what I can do is create I like to call this a TIE fighter plot. What I say is put the estimate on the x-axis, put the cuisine description on the y-axis, geome point. This is going to be an early start to a graph. Oops, I ran too many lines. Okay, early start to a graph. Next thing I need is to add our. Let's actually, before I do anything, I'm going to reorder these cuisine descriptions. Say fct reorder from the forecats package. The cuisine description based on the estimate. All right, already looks a little bit clearer. So now what I'm going to do is add error bar h, a horizontal error bar, and say xmin is conf low, xmax is conf high, and you're going to see why I call it a TIE fighter plot. If you're from Star Wars, we have these spaceships with a circle in the middle and then your wings facing out. Now this shows some confidence intervals for typical scores for each value. So we can see that donut places have the lowest. That might just be because Dunkin' Donuts is so common, and being a large chain, perhaps they're unusually good at regulatory compliance. And we have Indian at the top in terms of tending to have the highest scores. Again, that has been most violations within this data set. Finally, this is way too long. I'm going to want to recode that somehow. I'm probably going to go by saying cuisine description is remove from the description, remove everything after a parentheses. So this one, I just added a regular expression where I said drop all that extra parentheses. I'm also probably going to want to label this and say X is average violation, average inspection score, higher means more violations, and then say Y is type of cuisine. It's already being a pretty good plot. And while I'm at it, I like to, you've seen this if you watched the previous ones, I like to turn everything into theme light. I prefer that to the default ggplot2 theme. So notice what we did. We used t-test, t-dot test, a one sample t-test to calculate a confidence interval for each, and then we arranged them into this kind of this plot. All right. I had a hypothesis there. My hypothesis was that large chains tend to have fewer violations because they because they might be better at compliance. They might have lots of restaurants and a strong program that enforces that. So I theorized that maybe Dunkin' Donuts drives this. Maybe McDonald's and Burger King drive hamburgers being low, and Subway drives sandwiches being low. So for how are we going to examine that? Well, let's keep the most recent inspection. And let's do it by doing business as. So by like name of restaurant. If I counted the restaurants, I would see like Dunkin' Donuts, and also you got your code Dunkin' Donuts, Baskin Robbins. These are your top chains. I'd like to find out for each of them what the average inspection is. So I can say every one of these is a separate restaurant. These are 391 separate Dunkin' Donuts. We always have one row here per separate restaurant permit. So here we have summarize. So one I'm going to have is number of restaurants. Always good. I'm going to have average score is mean of score. Probably doesn't hurt to have the median score. I'd like to have those two next to each other. And let me see. I'm going to do these by arranging descending restaurants. Descending by the number of restaurants. So now I'm looking at these top ones, like Dunkin' Donuts. All right, immediately we're starting to get this sense that notice these ones. I'm going to throw in cuisine. I want to just call it cuisine. This cuisine description is such a long name. Yeah, what we're noticing is Dunkin' Donuts probably is generally driving down the average inspection score. Notice it tends to be around 9, which is one of the lowest inspection scores, the fewest violations. Similarly, we see Starbucks being a cafe and having a very low score that probably helps drive down relative to other ones. All of these are on the lower end of the spectrum. That is, this looks like the more restaurants there are, the lower their scores tend to be. Let's actually compare that. I'm going to call this by DBA, like by doing business as, by restaurant name, really. And let's actually graph this. Let's say, let me see. This will need to be on an x-axis. Okay, what I'll do is I'll say, but based on, pardon me, I meant on a log axis, number of restaurants, average score. I'm not so sure how good this plot's going to be. Geom point and scale x log 10. Okay. Yeah. Okay. So what we're seeing is almost all the restaurants that have really bad scores do have very few locations that are open. So maybe instead of restaurants, we'll call this locations. So up here are your chains, your Dunkin' Donuts and your Starbucks, and here are your individual places. Now the fact that there are lots of places with few locations is going to skew this a little bit. So what I sometimes do here is I'd want to make it a box plot, and I'd want to say. Let's see. I would say mutate locations bin is, I'm going to use the cut function that is built into R, and say cut locations into one. We have like 1 location, 3 locations, 10 locations, infinite locations. I wonder if I just counted this, how many locations would there be? Ooh, no, I need to ungroup after that summarize. That's why it took a minute. Otherwise, it stays grouped, and that is going to be, next step is going to be slow. Okay, so most places have exactly 1 location. Some have, this is, I really need to give this better names. What I'd say is labels equals 1. This one is just 2 to 3, 3 to 10, more than 10. Very few of more than 10. Very few being 57. These are your chains, really. And what I do then is graph locations bin, box plot, and I don't need this anymore. Oops. Oh, I don't want to count. I want to mutate. All right. So what this is showing is actually my earlier graph might have been a little bit misleading. It's not that all the bad that restaurants tend to be worse when they're not chains. It's that there are so many restaurants with very few locations that they that most of the worst restaurants end up in that group. So I wonder if I put the y-axis on a log scale. I'm probably going to need score +1. Remember, every dot here is like one chain or one name of restaurant. Okay, what this is suggesting to me is, notice these distributions are pretty similar for like places with 1, places with 2 to 3, 3 to 10, maybe it's shrinking a little bit, but in general the chain restaurants are a little bit less likely to lead to violations. Not as much as I kind of thought. Okay, but one of the reasons I'm doing this is that I'd like to count each chain only once when I'm calculating these confidence intervals. Otherwise, we're going to count every individual Starbucks as a separate restaurant. So maybe when I do this cuisine, I just want to count that as one location. So what I want to do is by cuisine would be by DBA. I'm going to call it cuisine from now on instead of cuisine description. That's what happened in that earlier aggregation. And I'll use the average score for each restaurant. So right now I'm doing this aggregation, but I'm counting each restaurant only once. So now all of Starbucks is aggregated into 1 point before it gets summarized here. Okay, and if I do this and I say by DBA, I count cuisine. Maybe I probably need to go to be not quite as strict here. Oops. Oh, average now AVG score. Okay. Okay. I'm guessing we're going to get slightly different results now, but this is going to count each restaurant only once, thanks to the fact that I'm working with the aggregated by DBA data first. It's a bit of like an extra step here, but it's trying to avoid that failure mode. I'm tired of calling it cuisine description. We've renamed it. Oh. Here. Okay, it actually is a somewhat different order now. Donuts is no longer on the bottom. Ooh, donuts isn't here at all because it's not once Dunkin' Donuts has been collapsed into one step, it's not common enough anymore. Okay. And actually the sequence looks better, but I do feel better about it. I do feel more confident in it. Average inspection score by type of cuisine. Let's see. And I quickly say each restaurant, each chain was aggregated, counted based on its average score. Once based on its average score, as opposed to counting each individual location separately. All right. The confidence intervals are a bit wider. It feels like we have less data, but I would be inclined to trust this data a bit more. It's not counting things like Starbucks shifting it. Okay, Indian food restaurants tend to have, at least by this measure, the highest number of violations. All right. Okay, so that's some thoughts about cuisine. While we're at it, oh no, I was considering we could look at borough, but as we saw earlier, it really looks like it's pretty similar across boroughs. All right. I want to take a look at violations. I want to know things like the most common violations and how violations are associated with other things like types of restaurants. All right. Let's see. So I'm going to go back to our original, like this is all of our violation data. And already we saw if we count violation code, I'm going to count the critical flag, the violation code, and the violation description all together. And yeah, it looks like the most common critical violation is mice or, oh God, mice or live mice present in facilities. Food? Food something. Food or food preparation area. This all seems very important if I'm going to be eating here. Okay, if I just pull violation description, the most common ones are, I did not sort. Food and or non-food areas. Okay. So we see some, among the common ones, we have some critical and some non-critical. Okay. I think, I'm just thinking about, does the word mice like appear a lot? Does it appear in slightly different variations? Or for that matter, vermin. If I said filter for string detect violation description, the word mice. No, it's just this one. What if I said mouse? Nope. Vermin? Nope. Okay, just the one. Cockroach? Really? Bug? I thought I saw the word cockroach. Oh, it was roach. Yeah, there it is. Life. Oh, God. Losing my appetite just reading this. All right, and so we have roach, vermin, mice. Those are some of the terms. Okay. Food, cold food item held above. All right. There's a question I sometimes like to ask about things like this. I like to say we already been looking by type of cuisine. Can we understand what types of violations tended to happen in one type of cuisine more than in others? So the way I'm going to approach that is we've got all of our violations, and they tend to be really long. It's going to make it hard to graph, but I'm going to ask, let's combine it with, I'm just renaming it to cuisine. All right, and what we have now are, let me see, I'm going to call this, I don't even need to save it, it's a pretty fast step. What this is showing one row for every cuisine type and saying how common was, oh man, I just realized I'm looking across all inspections. I don't love that. I might want to look at the most recent inspection only. All right, there's a way I can do that, which is that I can, I've already got my most recent inspections in most recent cycle inspection. I'm going to do a semi-join. I'm going to say here I've got all the data, but if I semi-join it on the most recent cycle inspection by both the restaurant ID and the inspection date, now I still have all the violations, but I have them only from the most recent inspection. Okay, and now I can count it. All right, now that I've done that, I can say group by our violation code, and I can say add how many times this violation appear total, and that'll be sum of n. So now I can say within this cuisine, across all cuisines, 02A occurred 43 times. In truth, that might be a number a little too low for us to really answer questions about it. I'm not sure. It looks like there are 84 separate violation codes. I'm going to ungroup. Okay. Or no, I'm going to group by slightly separately. I'm going to say group by the cuisine and say I'm going to add a separate variable of what is the cuisine total. So how many is sum of n? So I'm going to say within American cuisine, there were 15,000 violations within the most recent inspection, and 43 of them were for food not cooked to required minimum temperature. I said 43. I should have said 8 of them were for that. Okay, a bit better. And in general, this is a rare one. This doesn't look like a lot of people, like only 43 violations cited across everything. I probably want to filter that one out. I'm going to go ahead and say, let's ungroup, and let's filter for violation total is greater than, I don't know, 500? How many violations does that leave? If I count violation description at that point, 23 violations had at least 500 instances. Okay. So what I'm doing here is I filtered it down a little bit. So I said, let's only look at the most common violations. All right. And let's also look only at the most common cuisines. Otherwise, we're not going to be able to discover something. Afghan food, there's only 35 violations of the whole data set. We can't really look at frequency if we're going to look at it that way. So I'm going to say you must have at least, I'm going pretty arbitrary, you must have at least 1,000 total violations within the cuisine. This really is the most number of restaurants. Heck, let's make it 2,000. Just messing around here. Let's make this 1,000. Trying to make our job easy, look at within the math. Okay. All right. Why am I doing all of this? I'm going to say violation cuisine counts. What I'm trying to do is understand the relationship in this data between, are there some violations that are more common in particular types of cuisine than in others? Now I can say, let's see, violation cuisine counts. Yeah. Oh, and I probably want to add fraction equals, what is it? N divided by the cuisine total. This would be the fraction for each cuisine. So I'm building a matrix here, really. It's not apparent because I'm keeping it in a tidy format. But I'm saying for within all American cuisine, a full 3% of the violations listed were a hot food item not held at or above, etc. Okay. And now I can say, for example, let's arrange by descending fraction. What were unusually common violations? So what we find out is that for cafes, we see a lot of not critical, non-food contact surface improperly constructed. So this is usually the most common. Is that unusually common? Actually, kind of a little bit hard to say because it is common across all of these. All right. I'm going to, let's see. Yeah. I'm actually going to frame this a little bit differently. I'm going to say, after the count, let's add a fraction column. Then we group by violation code. Now I'm going to say cuisine total, and I'm also going to say, no, I need to actually, after this filter, there's a lot of group by and summarize. Here I'm going a little off the deep end here, but this just happens to be the kind of thing I've done a couple times before. If I want to take a look at group by violation description, I can say average fraction. After I've done all the filtering, I say the average for this violation, and you get kind of a relative risk. Oops. This needs to happen down here. Okay. Whole operation right here, where I'm saying, what I'm doing is saying that on average, each cuisine, for a typical cuisine, 6% of the violations are a hot food item not held at or above, etc. And we're saying that is unusually low for American food and cafes, a little bit high for Caribbean within this this violation. Now if I say, now I can even say relative risk, where we say the fraction divided by the average fraction. That is to say, usually we'd expect 6% of a restaurant to restaurant's violations to be hot food item not held at or above, etc. In this case, it's 3%. The relative risk is a little bit low. In some cases, it's higher than we'd expect. And now I'm not doing the kind of statistical controls I usually would. I'm just getting a feel for this data. But I would say, what are the highest relative risks? How much more common is it within each type than we would expect? And what we see is within cafes, it's unusually common to have food protection certificate not held by supervisor of food operations. All right, that's like twice as likely as you'd be expected across all cuisines. And similarly, we have proper sanitation not provided. We have raw cooked prepared food is adulterated, is contaminated, cross-contaminated. We have meat more common in American restaurants. All right, and hot food item is also unusually high within pizza and Caribbean. It's a little hard to interpret this. Honestly, I don't even know a lot about cooking, let alone like restaurant food preparation regulations. But yeah, we're getting some feel for if you were worried about which types of cuisine. This is done just statistically. This is not meant to be a guide to dining in New York or anywhere, certainly. But we just want to get a feel for which restaurants were unusually likely to do to have roaches. We could say violation code or violation description equals this one, and say roaches are a little more common in Latin and Chinese, least common in cafes and American food. That's an example. I could have said, what about mice? And I could have said, what types of cuisine might tend to attract mice? Caribbean, least of all, similar kind of order. This actually also makes me think about correlations. Are there types of violations that tend to occur together? I'm noticing that just because cafes are less likely to have your mice or roaches. All right. In my I've looked at this a couple different ways. We don't have a lot of graphs outside of my original one by type of cuisine. If I had more time and a little more experience working with New York data, I might have tried doing a map based on zip codes. We could have said what zip codes have the worst violations or this particular type of violation. I'm not going to do that here. I'm going to be interested in something. What violations tend to occur together? So we're going to use violations tend to occur together. Do I want to do this by restaurant or like by doing business as or by individual restaurant? I'm going to do it by individual restaurant, but I'm going to recognize the confounding factor that we have Dunkin' Donuts having lots of locations. But I'm going to start just by doing it on each restaurant. To explain, what I'm going to ask is let's take our inspection data. Let's filter for not is NA the violation description. Okay. Let's do that semi-join again. I want only the most recent inspection for each restaurant. All right. Now, how many restaurants are there? Count. All right. Sorry, I actually should say how many violations are there. Not too many. That's good. Because what I'm going to do is use the YDR package. We've used it a couple times in these screencasts. It's very good for finding comparisons between values, like between this description and another description, seeing how often they occur together. So I'm going to say pairwise correlation between violation descriptions occurring within the same restaurant, the same restaurant ID, canvas, and I'm going to add sort equals true to pairwise correlation. Okay. All right. The most common pair is, I wish they were shorter, but we generally see posted caloric content is, pull item 1 head. Posted caloric content on the menus, etc., is deficient in that it's not as prominent, and then this one is not posted. Okay, so it's very common to see, it seems like these two violations are almost opposite each other, in that one of them is, that one of them says it's too small and the other says it's not posted. But it makes sense, these are highly related violations. So are the next two. And oh, by the way, notice that each of them occurs twice because you have it in one direction and the other. So I can kind of read down this plan and say, next is facility not vermin-proof and evidence of mice. Makes some sense. If you don't have, if you're not vermin-proof, the mice can show up. Next two, I do not know what either of these mean. I don't know what HACCP is. And these are, oh boy, the vermin one and the flies. And the next two are food not labeled, and actually, these are a bit different. Oh, okay. Yeah, I think these don't pair up perfectly. Maybe based on ties in the sorting. Okay, but we do get the we get the idea. Now that I'm thinking about that, what I realize we really want is singular value, PCA, principal component analysis. What I'm really interested in is are there particular dimensions? Like the first dimension I could imagine that tends to occur within the same restaurant would be, within the same inspection, would be about animals or vermin. Mice, vermin, flies. But another one is about caloric labeling. Another one is might be about another might be about heat. So I'm actually and we see a lot of things about food temperature. So what I'm wondering is, do these make up common sources of variation? So I'm going to I'll keep this pairwise correlation, but I'm going to do something a bit different too. I'm going to call it here's our violations data set. Here's the step, as I often do at the end, I do a slightly more mathematically complicated operation. I need to remember, do I have this function set up? Widely SVD. Good for me, I do. All right, singular value this is a function set up in the YDR package. It turns it in matrix into it turns, pardon me, your tidy data set into a wide matrix. In this case, a combination of restaurant and violation. Then it does singular value decomposition, which is a way of doing principal component analysis, where it'll say instead of how would I explain this? It says, what are the main sources of variation? Like, what are the main things that tend to occur together, and you can simplify down a large list of violations into a smaller number of drivers of that variation. There's a lot of math that goes into this. I'm not properly prepared to teach it. I'm just going to show how I would use it in this analysis. And I'm a little out of practice with PCA, so you're going to have to bear with me a moment. What I would generally say is, let's see, this will end up in the item column. All right, yeah, I want to know the violation description. It's a binary matrix, so I'm going to set value equals 1 in all columns. Now I want to know the connection between violation descriptions and the feature that links one items to others. That's in this case the restaurant, the chemist, the particular restaurant permit. Third is the value. Do I need to many features? Yes, we have loads of features, so I actually need to say NV, the number of principal components to estimate. And I say, let's estimate just 6. So I'm going to say principal components. This is a tidy approach to computing principal component analysis. Let's find out if I didn't crash anything. The way this data sets up is that we now have 6 dimensions of violations. So this would be the first dimension would be everything from this now we will have one row for every dimension and every violation. So for example, this first dimension, if I filter for dimension equals 1, we have 78 separate violations. And if I arrange it in descending violation description, what I get are, arrange descending value. What I'm getting are, here it is, everything is less than 0. Oh, it's because of the normalization. Oh, man, I have the hardest time dealing with these, sorry to get you stuck, but I always forget about the normalization step within principal component analysis. But what I believe is happening, one moment, is that the most common things end up at the bottom. Yes, we actually do see this. Okay. The first principal component is a bit of a throwaway. The first principal component says each violation gets an amount of weight, in this case negative weight, but the weights are arbitrary, that is roughly proportional to how frequent it is. So we saw this non-food contact service improperly constructed. We saw this in another data set. If we in other times when we were counting the most common ones. I'm going to ignore the first dimension for now. We call it a throwaway dimension this time. If this were properly, I forget exactly how to normalize it, either by rows or by columns, but if we did it right, we wouldn't see that first dimension. But let's go to the second. If I'm right, this will represent a natural spectrum of one type of common violation to another. All right. And this is what I was referring to. In the second dimension, what we notice is our top ones are not vermin-proof, evidence of mice, filth flies, live roaches. And then we have cold food item that doesn't seem as related, but rats. So pesticide use. Mostly what we see are things involving animals and vermin pests. All right. The other dimension, we see a lot of things about food contact surfaces and general cleanliness, washed, rinsed. One of these dimensions is not necessarily better or worse than the others. That's not what we're analyzing here. What we're just seeing is these are two types of two like extremes of violations that tend to occur together. So what I could do with this is say, let's see, I would say top n, let's take the top 10 violations in terms of absolute value. This grabs the 10 most extreme variations and create a graph where we'd say violation description by value, column, flip the coordinates, and quickly do a reorder. I just remembered I need to do the reorder, but I also need to shorten it a bit. Let's say string, the substring 1 to 30. 1 to 30, let's find out how that looks. All right, it's not a very clean, I'm going to make it 1 to 60. You'd probably have just said first sentence and it would have been pretty good. But the general idea is we're seeing what are the extreme values. And they are, they're really 3 in one direction. Facility not vermin-proof, evidence of mice, filth flies. And 1 in the other direction, non-food contact service improperly constructed, to a lesser extent each of these. These are 2 extremes of a principal component. The third principal component will probably explain a little bit more variation with another 2 types of extremes. All right, and we add, this is between food contact surfaces. One is food contact surface not properly washed. Another is non-food contact surface improperly constructed. So we're seeing, we're seeing some kind of variation here. It's a little difficult. I might have expected it to be one dimension to be about temperature and the other something else, but we're seeing it's a bit more complicated than that. I don't know if there's a crisp this one's sort of a crisp conclusion. The 2 types of variations in restaurants are between various kinds of live contamination with animals or flies, and one about contact surfaces being clean. But this is one exploration of principal component analysis applied to a high-dimensional space, all of our violations in all of our restaurants. Okay, that's wrapping this up. And one thing I want to share is that this was a very quick and improvised application of principal component analysis. I didn't do a lot of really explanation of what each step means. I want to show there's a fantastic demonstration by my former colleague Julia Silge of understanding principal component analysis using Stack Overflow data, where she applies principal component analysis to find to tags on Stack Overflow to say here are the extremes on one principal component of types of programming languages. Everything from front-end web development, HTML, JavaScript, jQuery on one side, to Python and C++ on the other. Python and C++. This goes all the way from there to the second principal component, and she explores it some more and does some really good explanations of how principal component analysis can be done in a tidy way. Again, I'm not going to. I really recommend checking that out, as well as Julia's talk from our studio conf, if you're interested in seeing the speech all about it. So this was just a quick improvisation into that. All right, besides that, we also learned how to do a confidence intervals and a TIE fighter plot. We didn't take a look at geography today. We looked a little at were some types of violation a little more common within one cuisine than another. I don't think we got to too satisfying an answer. We generally understood a little bit more about the way that violations are recorded. All right. That was definitely fun. I'm really excited to see what everyone else comes up with for this Tidy Tuesday. I'm really interested in checking out the rest of the New York Open Data Portal that I've actually never really taken a look at, but I think it could have a lot of really interesting analyses. And that concludes this Tidy Tuesday screencast, and I'll see you next week.